So for this uh, checking the conductive hair loss and sensorineural hair loss, we conduct different types of hearing tests. One of them is the Weber's test. In Weber test, we uh, place the fork on the vertex of the skull, so through the bone, the stimulus reach the both ears. And here I have written test. So this is the stimulus. So if I place the fork on the vertex right in the middle, so the stimulus will be reaching both ears uh, simultaneously, and he will have equal intensity and loudness. Okay, and we have background noise also. So if I have background noise, which is represented by this thing, and this is the change in stimuli, which will be same for both ears, because it is reaching both ears at same time, and at same loudness will be reaching both ear, and this is the background noise. So I have the Weber's formula, which says that change in perception is equal to constant of natural log of change in stimulus divided by background noise. So suppose this is my left side and this is the right side. This thing show the change in stimulus, which in this case will be not changing because it will be same for both ears, while this thing can change for both ears. If the background noise is less on this side and more on this side, or more on this side, less on this side, it will be different. Like I am giving you one situation. Suppose on left side my background noise is greater than on my right side. So put in this formula, so delta S will be same for both here. If this goes down, so what, this value as a whole will increase now. If suppose S is 5, so it will be for right side I am doing, and for left side suppose. So delta S for both side is 5. Suppose I am only taking, and background noise for my right side, I'd say it is less than on the left side. So background noise for my right is 1, and for left side it is 2.5. So here I am getting 5, and here I am getting 2. So if this goes down as a whole, this value increase. So on the right side, if this goes down, my background noise is less, so this will be as a whole, this value will get increase. So my change in perception, or my noise, will be louder on right side, which I have already written this. And if suppose on the right side background noise is less than on the left side, so decrease in background noise on the right side will cause increase in this value. So right side delta S get increases, so louder sound on right ear. And Weber's test, basically I was explaining this for two things. In Weber's test, if you normally the loudness on both ears should be same, but if in one ear it gets louder, suppose on my right side I am hearing louder, which should not be normally, but if I have louder sound on my right ear, so it could have two causes. The first cause is that background noise here is less than that side, which what mean by if this decrease, so it mean that you have conductive hair loss here, due to which your background noise is less on this side, so you have conductive hair loss on ipsilateral side. So if louder sound on one side, it will have conductive hair loss on that side. And another cause for this louder sound on this side is this stimulus is reaching the ear through the bone, so it will bypass the conductive side and will through the bone conduction reach the cochlea, and then through the spiral ganglion, so to the central nervous system. So if I have sensorineural hair loss on this side, then stimulus will not be reaching through this side, and I will have louder sound on the right side. So if in Weber's test, if you have a louder sound on one side, then it could be due to conductive hair loss on the same ipsilateral side, while sensorineural hair loss on the opposite side. So if I conclude it will be simply in simple terms, it will be like this. If I have louder sound air, in which air there will be louder sound, so there will be conductive hair loss on that side, so ipsilateral conductive hair loss, while sensorineural hair loss contralaterally. Contralateral sensorineural hair loss, while conductive ipsilateral hair loss. So I think it is the best explanation I have ever found for the Weber's test. The Rennie's test is very simple, you could do it easily, but the Weber's test is sometimes it is confusing, so this is the best explanation I have ever found. So I think it will help you people.